Oh, there it is. And all right. Finally got myself straightened out here. So if you're done, feel free to turn your paper over and I'll come get it. If you're still working, don't panic. I know it takes a while, especially when you're writing sentences. And I only want a sentence on that last one. Please don't write any more than that. If you can hold yourself back. Nice. Is this one, or do you want me to take that as well? This one, okay. Oh, I haven't done it yet. I don't want to look.
You cheated then.
Well, sort of, I guess, but I'm going to pretend that I didn't. All right, you're all set over here. All three of these. Nice. Nice job. This one, excellent. There we go. There it is. All right, try to finish up that sentence that you're writing for the last part there. I'm sure that's all you're doing. Do your best, and we'll. Yeah, Oh, you have one there. Good, good. I'll take a look at what you have. Very nice. Good job. Good job. Excellent. All right, last couple here. I'm gonna look at that. Gotta wear blinders now when I walk in case I see your wordles. Here. So I don't want to see what they're doing over there. Thank you. All set? I'll give you 1 more minute. How about? Yeah, write it out. You can do it. Oh, oh, your sentence is a little longer. Okay, thank you. Okay. All right. Well, let's go ahead. I think I've got them all now. All right. Let's go ahead and take a look at my answers. And I noticed a little typo. You probably noticed it as well. SMAPLE. So I changed it to sample there. So the claim is that the average for honor students is bigger than the average for non-honor students. So you just take the statement up there, this belief, and stick it there in symbolic form. You're doing great. I saw a lot of these. And then, of course, the null and alternative hypotheses. I don't have a place for the opposite of the claim. It might be a good idea, though, whenever if I don't put in a place for it to actually do this, make opposite here, and then mu1 is less than or equal to mu2, just so that you have that in your mind when you're doing this. This thing is right-tailed. It's because of the alternative pointing that direction. Alpha is given as the significance level. The test statistic is 2.14. You got that off of the thing here. So you're just interpreting what is, and it even looks like test statistic, doesn't it? T-stat. So there it is right there. The p-value, you're just supposed to pick the correct one. And as I mentioned before, I generally read with you, which means that if you choose the wrong thing here, I'll take off there. But if you are consistent, then I won't take, you won't get double taking off. Like if you're like, it's left-tailed, and then you tell me the p-value is the left-tailed one, well, that's what you think it is. But anyway, so this p-value is this. So since this is less than alpha, you're going to reject the null hypothesis, and there is evidence. So whenever you reject the null hypothesis, there is evidence to suggest, you're always going to say that. And then this is the hard part, because you have to interpret your alternative hypothesis. So that's this one. Interpret that in plain English, and it's difficult. So you might say there is evidence to suggest that the average honor student is greater than the average non-honor student, or whatever. I've spelled it out a little bit clearer, but anything that refers back to what we're measuring is going to make me happy. So yours doesn't have to look identical to this. These always take a while for me to read, and the next exam, it's going to be a bit of a slog on Saturday morning, but it'll be okay. So there's only 24 of you. Usually there's like 38 here, so actually I've got it easy this semester. Yeah, average number of math credits taken by honor students is greater than the average number of math credits taken by non-honor students. So that's actually what we're measuring. All right, any questions? Looks okay. All right, very good. So we're going to switch gears, and we're going to do an, oh, and I apologize for the mess up. I told you in the email that I messed up on my on Wednesday with the whole thing, because I had this memory, this visceral memory of fall screwing up and having to correct it. And then I did it again. So I really apologize for that. So hopefully you got things squared away. If you're still confused, or if your spreadsheet still doesn't work, let me know. Some of you might have gotten lucky. And if you're, so here, let me just show you. I actually, when I was trying to find, so this was the two means different variants. I had the wrong formula for degrees of freedom, and the real formula is really nasty. But anyway, I had a hard time finding an example on Newton to use in the video, because I kept getting the ones that you would have the same variants. So you might have gotten lucky and not needed that part, which is fine, but I just didn't want anyone to struggle with your homework. Anyway, getting back to this, we're going to do two proportions today. So we're comparing two proportions. And so as an example, let's do a little survey. And here's my belief. Let's see. I think that the percentage of women who own iPhones is greater than the percentage of men who own iPhones. So I've got an iPhone, but I look around and I see these guys who have their Samsungs or their Hawaiis or whatever they're called. And I think, okay, well, maybe dudes prefer Android and women prefer iPhone. So I'm kind of curious. And so let's do a little survey. Now, as always, whenever I survey you, you either can choose not to participate or you can choose to lie to me. That is totally fine. I don't care. So this isn't, it's not a big deal. So here's what I want to know is I want to put you into one of these four categories. Do you own an iPhone? And there are 4 categories. Either you own an iPhone and you're a female, or you don't own an iPhone and you're a female, or you own an iPhone and you're a dude, or you don't own an iPhone and you're a guy. So let's go through and see if we can, so if you would indulge me so I can have some data for this. So how many of you are females and own iPhones? And you're proud of it, apparently. 1, 2, 3, 4, 5, 6, 7, 8. 8 of you. So 8 of you, yes. Now, what about the people who are no? The no, don't own. Okay, that's 1, 2, 3. Interesting. Now, what about the opposite? Or we'll do the guys. So men who own iPhones. Okay, so I'll conclude myself just so we have more data. 1, 2, 3, 4, 5, 6, 7. Very nice. And then men who don't own iPhones. 1, 2. Okay, 2. All right, well, this isn't going to work out the way I would hoped, because those are almost exactly the same proportions. Well, not only so, but we have the same issue that we do with, you remember when we were doing the hypothesis test for the proportion, it made a big deal about whether or not we were allowed to use the hypothesis test, and the whole business was whether or not we had a large enough sample size, and the cutoff was 5. You want to have 5 people at least 5 people in each of your categories to do this. And here, clearly, I have fewer. I knew that that would be the case. But nonetheless, I'm going to pretend that I can do this, and I'm going to actually do this here. So there's my data. It's a little disappointing, to be honest, but that's okay. So here's how I'm going to do this. The percentage of women, this is the iPhone question. My claim is that the percentage of women is greater than the percentage of men. And I believe that actually it's fine. So this is a little disappointing. Okay, so that's my claim. The hypotheses, null hypothesis, will be the percentage of women is less than or equal to the percentage of men. The alternative is the percentage of women is greater than the percentage of men. So remember to use P for percentage, mu for average. So you have those two. Let's see how we're going to do this. So this is a little bit, oh, that just showed right up there. Just a minute. That's blocking all the rest. Sorry. Let me just fix this. I was working on it earlier and I think I messed something up. Hold on a minute. Here we go. Let's see, can I fix this? Animations fade. Okay, yeah, that's better. Okay, try this. Much better. There's some stuff that showed up, but we'll ignore that for now. So we're going to have the following things that we're going to have to keep track of. First of all, we have a proportion for population 1. You have a proportion for population 2. That P hat with a 1 on it, that's the proportion for sample 1. So that's like the proportion for the sample with the women, and then the proportion for sample 2. And then this is called the pooled proportion. It's kind of hard to see here, but there's like a line over that P. It'll be bigger in just a minute. So anyway, you have all of this stuff, and we're going to do basically the same thing we did Wednesday, but with proportions. And so the big difference is we're going to use normal distribution instead of the t-distribution. And here is the formula for that z, the z. I wouldn't write that down. I'm just using this as a guide. Here's what I'm going to do, is I'm just going to crank this in here real quick. There it is. Oh, oops, there it is. So here's all the information we need. Here's our hypothesis test gold, and we're going to get to it and actually set this up. It'll look similar to this, but it'll be for proportions, and then you'll be able to do the proportions. Now, for those of you who did the Newton homework the way that Newton wanted you to do it, using the data analysis tool pack, I don't know if anyone did that. If you did that, you can't do that with proportions. So that's part of the reason why I prefer to just do it all the same. So it's all similar. Okay, so let's get to this and see if we can put this all together. Give me a sec here to switch gears. There we go. Okay, so on your spreadsheet, if you have this, I'll give you a minute in case you haven't set this up. Oh, and there's nothing to download today, so don't fret. I just added a new sheet. You can do this by pressing this little plus down here. You'll get a new sheet. You know how to do this, hopefully. And I'm going to name this new sheet. Just a sec. once this zooms in, there we go. I'm going to name this 2 proportions. So this is 2 proportions. That way we'll know what we're doing and we know what it is. So I'll give you a minute to get yourself set up while I get myself set up. I should have told you to have it all ready before we started. So let's see, zoom way in. There we go. Okay, so hopefully everyone's at least sort of close. So I'm going to just put in the basics. Whoops, this is way over. Here we go. So as with on Wednesday, if you put your stuff in the same place as mine, then all the formulas will be easier to figure out. If not, you can always watch the video later. We are recording, and hopefully it will be obvious. And hopefully I won't have to do an addendum like I did yesterday. So here are the important things. We have x1. We'll talk about what that is in a minute. In1, x2, and in2. So that's pretty much it. Oh, I guess we also have the null hypothesis, H0. That's pretty much it for the data. So this is all of the stuff that you're going to be inputting. I'm not going to highlight this green yet, but this is all you need to type in. For each problem that we do, you're going to have these 2 things for the first sample, these for the second, and then the spreadsheet's going to take care of the rest. But walk through this with me. It's not that complicated. Even the thing there, that Z is not that bad. Okay, so X1 for us, let's see, where was my, there it is. We had, oh, you can't see it because it's, let me move this over a bit. So X1 is going to be the number of women who own iPhones. So in this case, it's 8. In1 is the sample size for the women. So that's 11. You'll notice that we have 11 women in the sample. X2 is the number of successes in the min, among the min. You know what? I'm going to delete myself from the, here. I've decided I don't count. Here we go. That'll make it at least a little bit better. But yeah, I still think I'm going to fail this one. Okay, so 6. So we'll call it 6. 6 of you have iPhones if you enter guys. And then out of 8, there were 8 men. This sample size is way too small. We shouldn't be using this hypothesis test. So if it ever asks you, are you allowed to use a hypothesis test? Make sure all of these numbers are at least 5. And also, well, all of these numbers really. But in this case, we're just going to go ahead anyway. The null hypothesis is the difference. So going back here, you'll notice that I have this written like that, but as before, what this means is that the difference between the 2 proportions is 0. So once again, we're always going to have 0 for this class, but if you take the advanced statistical methods in psychology with Dr. Kwan or some other advanced statistics, you might be using a different number here. So I just want to make sure this is as robust as possible in case you want to use it again. I don't know, maybe you'll just trash this after this semester, whatever. Okay, so I'm going to use 0 there. So that's the setup. Now let's go back to the formulas. So here are all the formulas. It looks like we're going to need a population 1. Oh, no, here we go. How about this? P hat 1. We're going to need that. That's something I can compute. I can compute P hat 2. Those are the sample proportions. So a sample proportion is easy. This is going to equal the number who said yes divided by the total, the sample size. So 72% of the women said that they had iPhones. Now let's compare that with the men. This is going to equal the number of men who said yes divided by the total number of men, which is, as you can see, already I have failed in my, if you ever, here, let me just go back to the, where was the claim? Here, where is it? There it is. Yeah, this claim, you know, if you have a claim like this, that the women is bigger than the men and your data is that the women is less than the men, you've already lost. So, you know, but anyway, we're going to barrel on ahead even though I've lost. I don't care. I'll just keep going because we need the spreadsheet. So if we had a few more men here who had Androids, maybe this would have been better. In fact, no, I won't do it. I was going to say let's lie about it, but we'll stick with these numbers and we'll fix it. You'll see. There's some other examples that actually are not failures. But let's go on. So we have those, and then we're going to need this P bar. So the P with the bar over it, the P bar, that's the pooled proportion. That's what we get when we take everyone, put them all together in one big group, and ask, well, how many of you as a big group have iPhones? So that is a little tricky, but it's not too bad. I'll show you how to do it. To do P bar, what you're going to do is you're going to take everyone who has an iPhone. So this is going to be these people. Those are the women with iPhones. Add that to the men with iPhones and put it in a set of parentheses because we want to put them all together in one big happy family. So you've got all of the iPhone people, and divide this by the sample sizes. So we're going to add the sample sizes together. And so you can put this in parentheses as well. This will be N1 plus N2. Close the parentheses. And then there you go. So this, I'll put this back up here. It's 73%, 74% if you round. I'll put it back up. So this is just, if we put everyone together in one big sample, what would be the percentage of iPhone people? All right, so far so good? All right, let me know if you get stuck. You know how the deal is that if you get stuck, it's better to stop early. And I actually had, what was it? It was in numerical methods on Wednesday. I think I had to go around to 4 people and be like, fix this, fix this. We were doing Python. It was not Excel, but there was like someone had left. It was just a tricky thing that we were doing. Okay, so we've got that. Okay, now what we're gonna do, or the way that I like to do this, is I like to deal with this denominator first, because that's really tricky. There's a lot of stuff going on here. So let's do the denominator, and then after we do the denominator, we'll put it together and get z. So the denominator is what's called the standard error. It's like a standard deviation. You've heard this before, the standard error for this particular hypothesis test. I'm going to just, actually, I'm going to shift this over this way because I want to make sure I have enough room. Okay, so basically, I'm just going to do this square root. It's not terrible. And by the way, Q bar, that's 1 minus P bar. So you'll see that's the opposite of, so in other words, this is the percentage of iPhone people. Q bar is the percentage of non-iPhone. I guess technically you could be using Blackberries or flip phones, but whatever. That's the opposite. So let's go ahead and do this. This is going to equal the square root. And so now bear with me here. This is going to be a little tedious. We do P bar times, in parentheses, 1 minus P bar. So this is P with a bar over it. This is Q with a bar over it. And now in parentheses, so we have to multiply this by 1 over the first sample size plus 1 over the second sample size. So here is the final here, and close that parenthesis. There's that square root. So a lot of stuff going on, but it's not as bad as what I sent you yesterday in that email. That was truly ugly. And I think I was just thinking, maybe I don't have to do that this time. I did have to do it, but hopefully it all worked for you. If it doesn't, by the way, if you're stuck with yesterday's thing, come see me and I'll type it in for you if you need me to. But here, so this one, let's see what number do I get here. The standard error, it should be 0.2. So if you don't get 0.2, then you got something wrong. I'll make this big again. There you can see the formula, 0.20 something. Good. Good. Okay, no one's yelling at me. Okay, so now I'm going to do z, and then from there on in, it's going to be pretty much the same as our 1 proportion. So this is going to be z. test stat. So when you get to Newton, if it asks you for the test statistic, that's this number. We'll test this out in a minute with Newton. Okay, so this thing is pretty easy. This is a z-score. So this is going to equal the difference in my proportions. So let's get this straight. P hat 1 minus P hat 2. Ooh, I need another set of parentheses. Okay, let me just fix this. I just hit enter. That's not the correct answer. So I need to put another set of parentheses there. So if you hit your arrow key here, anyway. So it should be a parenthesis, then B6 minus B7. So I have everything up here, and then this is the null hypothesis. So we're just, the null hypothesis is that there's no difference in this case. So that's going to be, oops, what happened here? Click that, there we go. And then you're going to divide this by the standard error. That's B9. There we go. Oh, why is it, what just happened? I think I messed up. I clicked something weird. We try again. B6 minus B7, all of this divided by B9. There we go. Okay, so that's it. Certainly, there you go. Yeah, it just took, since I started badly, I'm ending badly, I guess, with this one. But now we're almost there. Now I'm kind of curious to see if I can just copy everything from the one proportion. I think I can. Let's see if it works. So here's what I'm going to try. It would save us some time, but I can show you the formulas. But if you go back to one proportion, if you have that, if you don't have it, don't worry. I'll show you the formulas. But here, let's see, escape. So it's negative 0.111. Okay, so go back to one proportion. I'm going to grab all of the p-value stuff, just those 4 lines. And let's see if this works. Copy that. And then I'm going to go over here to 2 proportions, and I'm going to paste that right below. Ooh, it worked. There it is. So these, I believe, let me double check. I'll check them. Yeah, that's perfect. The left p-value is the norm.s.dist, and then this is the right is 1 minus that, and then this one 2 times the minimum. Perfect. So if you don't have your one proportion sheet available to you, I can go through this. I'll go through it relatively quickly, but you'll have to type in this stuff, p-value left, right, 2, and then here's the formulas. The first one is norm.s.dist. Whoops, why is this not letting me? There it is. Norm.s.dist of this number, and then true. I'll just give you a minute. Then the next one, you can double check yours. Yeah, so you'll have the same things. This one is just 1 minus the previous one. Right-tailed is just the opposite of the left-tailed. And then the two-tailed is 2 times the minimum of those 2. And that should do it. So I'll just pause for a minute, make sure that we're all in the right place and have these. So I know I just copied, it was super quick, but if you didn't have that to copy, then you'd have trouble. All right, let's go ahead and see. Oh, first of all, let us highlight. I'm going to highlight all of this stuff yellow. There it is. So that stuff, so the stuff below the H sub 0 is yellow, and then this stuff I'm going to highlight green, although with the caveat that the null hypothesis for us is pretty much always going to be 0. It will always be 0. It'll never be anything. But you could imagine that in your advanced research methods with Dr. Kwan or whoever it is, if you're in, I don't know if social work does that, but whatever, you might have a situation where you're wanting to know, is the proportion in this group more than 10% or 10% more than the proportion in this other group, in which case the difference would be like 10% or whatever. But for us, it's always 0. Well, like I said, this one was disappointing for me. The reason being that the p-value, this is a right-tailed test. The p-value for this right-tailed test is 0.54, well above any alpha. Alpha is never that big. And so I'm going to fail to reject the null hypothesis, and there is no evidence to suggest that women have iPhones, or proportion of women with iPhones is bigger than the proportion of men, at least from my sample. Now, my sample was pretty small though, so if I had a bigger class, which I've had in the past, sometimes I actually have a difference, but not this time. What do you think, Hayden? Yes, that's what I sometimes do as well. Wait, did I ask this question? I might have asked iPhone. Yeah, I sometimes will the survey I gave you at the beginning of class, sometimes I'll do that for all of my classes, so I have like 100, because usually every semester I have about 100 students when you add up everyone. But yeah, this semester, no, not so good. Okay, anything else? Any problems with this? We're going to leave this up here because we're about to use it. So let me pull up. I have some in the PowerPoint. I guess we could do the PowerPoint. That's fun. So we'll compare two population proportions. We'll do this one, and then maybe we'll take a look at Knudten and see if there's anything that we can do. So let's look this over. I know a lot to read. I'll zoom in a bit. But here we are. And I should say, nothing political here. I wrote this before the pandemic, so I probably wrote this back in 2018 or 2017. I don't know when. So yeah, this is just a case. My mother was in the nursing home at the time. She had a stroke in 2016. But anyway, go ahead and see if you can sort this. Oh, what I want is the claim, I guess. Get that, the claim. That's all. And I will get my randomizer. All right, does everyone have a claim at least that you're zooming in on? Do you see the word claim? Oftentimes the word claim will show up. Anyway, Elizabeth, do you see the claim? Do you have a claim? You have a claim? Zoom in there. Yeah, but you're not going to write that on a test. You're not going to subject me to reading that sentence. How would you write that in terms of symbols?
How would I write that? Sorry. So they would write like a little U, and then proportion. They write a little big P.
Very good.
And then they put like L.
Okay, PL for P large.
And then they would put the sign, like a little cross out inside.
Okay, and then.
Or no equal, yeah, because it would go.
I know. No difference is confusing because it sounds like a negated thing, but really no difference means that they're the same.
And then you put a little S.
Very nice. Perfect. There's the claim. Now that we've got that, let's get our opposite of our claim. Hey, Zeus, you know the opposite of this claim, don't you?
Yeah.
What is it?
Like the equals with the line, like.
And then I put all the same symbols, right? But I put that equals with the line, the one that Elizabeth originally wanted, but I wouldn't let her. Very nice. Okay, so there's the claim, there's the opposite. Now we have to figure out which of these is the null hypothesis and which is the alternative. Trinity knows though. Trinity, which one of these is the null hypothesis? So the null hypothesis is the no difference hypothesis. So which one I don't think I heard you. Equals, you said? Equals, that's what I thought. Okay, very good. So equals is the no difference, the null hypothesis always has the equal sign in it. Very good. And so, yeah, look for the one with the equal sign in it and name it the null hypothesis. The other one is going to be the alternative hypothesis, the not equal to. Yeah, I know it's hard when you have an equal, it looks like there's an equal symbol in both of them, but in this case, the one that matters is the one on the left. It has a true equals. The other one is not equal. Okay, next, we need to, what do we need to do? Oh, I know what we need to do. We need to fill out our spreadsheet here. So notice that we have these 4 items. I'm not going to mess with this, but these 4 items. So I want to find x1, in1, x2, and in2. Let me list those over here. So give me a sec. So I have, okay, change to red, blue. So I have x1, in1, x2, and in2. Now you could do this one of 2 ways. So I play this game one of 2 ways whenever I do this. One way I do it is I look for numbers and I say, what does that number mean? The other way I could play the game is I look at the symbol and I say, can I find that symbol up there? You could do it either way. I don't care. And so whoever gets picked first gets to choose how we play this game. Either do we look at now here's what I mean by looking at the numbers is there are a bunch of numbers here that I see. Yeah, there's a bunch of numbers. I want to know what those numbers mean, or, that's probably the easier game, right? Yeah, let's do it that way. Let me highlight the numbers, and we'll just identify what each of those means. Okay. All right, Kirsten, what does that 34 mean?
That 34 would be
Total population of the small nursing homes. Very good. So I think that because of whoever started this ball rolling, I think that's going to be in 2, is it not? Yeah, because, just because the small ones were second. So we're going to do that, but that's perfect. It's the number in the sample of the small nursing homes. Very good. All right, Joshua, what about this next number, 24? What's that? In 1, that's the number of large nursing homes that were sampled. Very good. Next, we're going to do Carson. What about that number 12 there? What does that represent? X2, very good. It's the number of small nursing homes who properly vaccinated their, so think of it this way, is that we're going and we're saying, do you use whatever it is, like do you vaccinate correctly? And they say yes or no. So 12 of them said, yeah, we do. We make sure that we don't have a flu outbreak. And then we need one more person that person's not here, but Caleb, you're here. Caleb, tell me about 17. Where do I put that? It's X1. It's the number of the large nursing homes who say, we make sure that all of our, or a large proportion of our residents are vaccinated. So you don't have to worry about a flu breakout. And so there are a couple other numbers there. Let's see if we can figure out what they are. So let's see, Will, what do you think of this number 80%? Does that have any bearing on this problem? Yeah, it's like, what is it? I don't know. Yeah, it doesn't. Sometimes you're going to see numbers in the stem of the problem, like here, where that 80%, I don't know, it doesn't really have any bearing. Technically, that could be anything. You could make that 90%, and that's just what the researchers were using as the bar to say, do you vaccinate enough or not? So, but it's not going to be something we use in our calculations. What about that 0.05? Maybe that has nothing to do with this as well. Let's see, I keep getting repeats. Anna, you're here. Anna, do you know what that 0.05 is going to represent?
nothing useful for us.
Nothing at all. Nothing useful. Actually, it is somewhat useful, a little bit, just a little useful. We have a name for that 0.05. Can you guess what the name is? It is alpha, yes, so it is sort of useful. We're not going to use it in our calculation. So you're right there. We're not going to use it in our Excel spreadsheet, but when we go back to this to say, do we reject the null hypothesis, that's going to be important. So maybe I should have put this here, and then Anna would have said, yes, it is useful, but there it is. It is. But you're right. When we do our calculations, not going to be all that useful. So let's see. Can I do my calculations with this? Well, I can see it here. You've probably already typed it in. I'm going to just type in these numbers. So we have X1 is 17. We have N1, which is 24. Those you can see right over there. Then down here, I've got 12 and 34. We're not messing with this. Okay, so one more thing before we evaluate this. We're pretty much done with this, by the way. It's that quick. Once you have that's why I call this the gold spreadsheet. It's so good. But let's see, we need to know how many tails we've got, or is it left or right tailed? Let's see, you're not here. But Avery, you are here, and you know, is this left-tailed, right-tailed, or two-tailed? It is two-tailed. Once you see that not equal to thing, you know two-tailed, two-tailed, two-tailed. And so this thing, two-tailed, we're going to use the two-tailed p-value. Let's go back here. There it is, two-tailed. Whoops, that's the z statistic. Let's go down further. There it is, two-tailed. The p-value, I'm going to jot this down over here. I'll show you what I'm writing. It's behind that. So p-value, I'm just copying it down, is 0.00767. Oh, I need to show you something about these p-values because I think it might have happened on the homework last night, but it will definitely happen in the future that some of the p-values are going to look really weird. So I'll show you that in a minute. But first, let us look at the conclusion. So the p-value is this, alpha is this. I need to make a decision. So the decision, remember the decision is just a very short statement. The conclusion is the big long one. I'm not going to write that down because I don't have enough room. But the little statement, let's get that little statement out of the way. Hayden, do you know what the decision is? Excellent, that's it. Just reject the null hypothesis. You don't even have to say that we do it because, well, we know that it's us. But yeah, you're going to reject. Reject, don't forget to put down null hypothesis. The p-value is less than alpha. That's why Hayden said that he's going to, I should have made him verbalize that probably, but you don't have to write that. You just have to say reject the null hypothesis. Some people, some students, when they get to the test, they'll write p-value is less than alpha. I guess it's just because you're thinking and you're writing what you think. That's fine. You can write it down. And it, you know, when I see that, I think, you know what you're doing. You're not just taking a guess, but this is all I really need. Finally, the conclusion. The conclusion is that there is evidence to suggest that the proportion of, that there is a difference between the proportion of large and small nursing homes with a vaccination rate less than 80%. So, oh, I just realized that these are the bad nursing homes, not the good ones, the way that this is, right? Because it says less than, so those are the bad ones. So actually, it's the large nursing homes who are doing a bad job, not the small ones, maybe, I don't know. But nonetheless, there is a difference. The problem there is hard to read. Let's take a peek at Knewton in this last couple of minutes, because I want to make sure that that Newton will be happy with us. Oh, actually, more important than that, let's do this. Let me show you something about this. So what's going to happen in the future is you're going to find, let's see, I'm just going to make up some numbers here, 50 out of 100. We're going to compare that with 80 out of 80 out of 90. Let's just do that. Oops, out of 90. Thank you. Okay, so let's just suppose that you're comparing two samples, and in sample one, you have 50 out of 100 who have whatever trait it is. We can make something up. Let's say that we are comparing students who live in whatever that dorm is over there. Oakwood, thank you. I couldn't think of it for a minute. Oakwood with Pioneer. So in Oakwood, it turns out that 50 out of 100 of the students clean their rooms once a week. And in Pioneer, it's 80 out of 90 clean their rooms once a week. And we're comparing those two, or whatever it is. You can make up your own story about this. But the important thing is to note that when we get down to looking at the p-values, notice what we have here. What in the world does that mean? I know some of you are like, I know what it means because you're scientists, but some of you are not. And so if you look at that and you see letters, what that means, and I know this technically isn't correct, so you scientists just keep it to yourself, but the way that you should interpret this is that this is extreme, E for extreme. So this is 4.3 times an extreme number. And this is an extremely small number. You see the negative there? If it had a plus there, it would be an extremely big number, but this is extremely small. So whenever you see this, just think it's basically zero. It's so small, it might as well be zero. So that's going to come up more and more as we go through our semester together, because there are some things that we do where we encounter this quite a few times. But it is okay for you who know scientific notation to think of this as 4.3 times 10 to the negative ninth. But those of you who are not as scientifically inclined, it's fine to think of that as being just extreme small, might as well be zero. So if you see that, you can type zero into Newton and Newton will be happy with you. Yeah, I don't want to do Newton now that I've done that, but I'm pretty sure that the Newton will be fine for Monday. Do let me know if you do have issues and we will deal with them. So I hope you have a great day.